share presentation again. We reach this point for subsurface safety valve. I will share one video about the subsurface safety valve. You can see the video, right?
Yes.
Here, how to control the subsurface safety valve from the control line. Let's look. They give pressure now to open from hand pump to open the subsurface safety valve. This is the flow tube. Now is completely open. They will start to close now. Will start to bleed off the pressure. Look here. They start to bleed off. So retract again and close. Okay, moving to talk about the perforated joint. Another section in the completion string. Here is the place for the perforated joint. Usually the perforated joint part or section from tubing with connection pin and box connection, perforated with slot here, manufactured in the workshop and designed to allow to the flow to coming through this point up to inside the string. What is the function for the perforated joint? Usually it is installed above XN or no-go nipple, the bottom nipple here. You have two functions. First function, if the bottom for the string is plugged, so you have another pass for the flow to coming inside from the perforation inside the tubing. So it is designed to provide temperature and pressure flow reading installed above gauge hanger landing nipple or no-go landing nipple, the bottom nipple. Usually we can hang memory gauge in the bottom nipple here to read the bottom hole pressure and temperature while flowing the well. If this one is not installed, the perforated joint, so let's check what will happen. There is two here situation. This one in the left without perforated joint and in the right with perforated joint. If you don't have perforated joint above the XN nipple, you hang in the XN nipple here gauge to read the true temperature and the pressure while flowing. So the flow will come from through or around the gauge hang in the nipple. It will pass and start to vibrate the gauge itself. So it will affect the flow for the well. It will affect the reading for the true temperature and the pressure for the hole and give you false data accusation or data from the well. Flow turbulence created in nipple, gauge vibrates, can cause also gauge damage and effect on the reading for the downhole temperature and pressure. But if you complete the well with perforated joint, so now the flow will come little around the gauge or the nipple in the nipple, and the flow will come through the perforated joint. So there is a stable flow through the gauge. It gives you true data accusation. Flow through nipple and perforated joint, that means less or no vibration. Gauge will be saved through data for bottom hole and temperature reading. This is the main purpose to install the perforated joint above the XN nipple. After that, we'll talk about the production pucker. The main purpose for or design for the production pucker is to seal between the casing and tubing, allow the reservoir fluid or oil and gas to be contained through the tubing to the surface and is not going through the annulus area, which is isolated by the pucker here. So it is prevent the casing from erosion or corrosion. What is the features or the component for the pucker? You have slips. The slips is to grip or catch on the wall for the casing, and packing element to seal with the packing element on the annulus from the tubing. The pucker can be different type, like permanent pucker. This one is set inside the well bore first before we running with compression string. It can be set by slick line or wire line, E-line, electric line, or it can be set with drill pipe. After that, we run with compression string with the retrievable pucker and sting inside the permanent pucker. So it can be permanent pucker. We cannot retrieve after set. Only the way to retrieve is to mill. You're running with milling tool to mill and drill the permanent pucker and drop inside the well. Then we can make fishing operation. Retrievable pucker, this is part or integral part from the pipe, connected pin by box with the tubing string while running in the hole. After running to setting depths, we start to pressurize up with the hydraulic setting. After you install nipple, plug in the nipple below, and at certain pressure, the slips will start to retract in the wall of the casing. Then you set some weight to energize the packing element to make the seal process. The retrievable pucker can be single, like this one, or can be dual. If you are going to run with dual string, short and long string, or can be triple. Here, this one is type for DB permanent pucker. This one is R. R refers to retrievable pucker. This one RH, retrievable pucker H. This one refers to hydraulic setting, setting by pressure. This one is R, retrievable, dual, or the and hydraulic pucker. This is dual. You have two pour to connect two string. Here, single pucker. Pucker can be set by E-line or wire line, or tubing or drill pipe set. It can be set with electrical signal from the surface by electrical signal by wire line, or it can be set mechanical or hydraulic. Mechanical, that means in the vertical well, you need to have rotation to energize the slips and packing element, or with the pressure from the surface, you break some screw, then you energize the packing element after the slips is hang or grip on the wall for the pipe, for the casing. Sorry. This is the production pucker, how to set, hydraulic set. You run, you drop ball here in the nipple or profile, then you start to energize or pressure up inside the pipe. So there is screw or shear pin here. It will start to break at certain value for the pressure based on the design and number for shear pins. After the shear pins is broken or are broken, the slips will start to grip out from its place on the casing from inside. Then you install weight so to energize the sealing or packing element. So now you can pressure test the annulus area to make sure that the pucker is sealing tubing from the annulus. Here the permanent pucker integral casing part and run independently. So it run before the production running. This is the permanent one. Remove or retrieve by milling, can be E-line or hydraulic set. The retrievable pucker here is part from the tubing, run and retrieve with the production pipe. If you need to retrieve again the retrievable pucker, you will just pull on the string to retract again the packing element and the slips from its place, waiting some time after to give time for the packing element to relax again, then you start to pull out the compression string, including the retrievable pucker. There is another type here, it's called inflatable pucker. This well intervention application mainly used for zone isolation or leakage interval. If you have leakage interval, this is 2 sections for pucker to isolate this zone of leak, and run on cold tubing usually. While pumping with pressure, the pucker start to inflate in the size and stop the leakage zone. Production pucker accessories. You have different accessories can run with the production pucker, like the locator tubing seal or seal bore extension, or anchor tubing assembly like this one, or polished bore receptacle, which is called PBR. The PBR usually is top section on the permanent pucker. Above the permanent pucker, there is PPR, polished bore receptacle. It is attached on the top of the permanent pucker to accept the seal assembly. So in this case, you have permanent pucker and in the top PPR, then you're running with seal assembly at the end of your tubing string. This is the seal assembly. You have package for different seals section, and you have no-go shoulder on the top here. This seal assembly sting inside or run inside the PPR. The PPR has profile to accept the packing element. By this way, you're running to sting completely inside its place. So your tubing now is isolated from the annulus with the packing element, so you can produce from the well. This one, no-go shoulder. Why this one is here? To locate that you are staying completely inside the PPR. When this no-go shoulder is coming in the top for the PPR, we will tag at the top, so you know that you are completely staying with the seal assembly inside the PPR section in the top of the permanent pucker. This is the locator seal, equipped with series of external seal providing effective seal between tubing and pucker bore, incorporate with no-go shoulder connected on the bottom for the tubing. So this part for the compression string at the end to sting inside the PPR at the top of the permanent pucker. There is seal bore extension. This can be, instead of connected to the top, it is connected to the bottom for permanent pucker to accommodate greater tubing movement. This is for movement or elongation for the pipe during production. And another type is called anchor tubing assembly. This anchor have slips and seal. Anchoring and unlatch feature with insufficient tubing weight stay in place, connected to the bottom for the tubing. This is connected to the bottom for the tubing. You have this anchor in the or slips in the wall for the casing, and you sting inside the top for the pucker. If you need to release the seal assembly to pull out with the tubing to recomplete the well, you will just pull on the tubing at the surface, so the seal assembly will start to coming out from its place. So you're pulling out with the tubing string to replace any part, and the permanent pucker with PPR will be stay inside the well. Clear? Any question?
All good.
Okay. This one is thematic for the accessories. If you look here from left to right, This is the seal bore. This is the PPR in the top for the permanent packer. Here is the sting in with the packing element or seal assembly inside its place, so you can produce through the packer, through the packing element from inside through the pipe. So this packing element isolate annulus from the string to not allow the flow to come in the annulus area. After you sting in usually with the seal assembly and space out, you pressure up the annulus above the packer already tested to make sure there is no communication between the pipe and the annulus. This one is another type which is called seal bore extension, SPE. This is from bottom of the permanent packer, not from top, and also it can accept also the seal assembly section. This one is another type, is called tubing seal bore receptacle, TSR. You will find the packer here have extension on the top, and the tubing seal receptacle contain the packing element from inside. When it is come inside its place, it will seal tubing from annulus, so we can produce through the pipe or the production string. So different design for the accessories, just to isolate tubing from annulus to facilitate the production fluid to come through the tubing without leakage to the annulus area. This is different types according to the design for the well. This one also, you have here permanent malleable packer. Here you have the locator, here seal assembly, this 4 section for seal assembly, and this is the PPR section on the top, and you are completely till you tag with the no-go. You coming with all seal from outside inside its profile to seal tubing from annulus, and this is the permanent packer, and you have below the permanent packer tailpipe contain landing nipple. This landing nipple to install the plug below to set the hydraulic permanent packer after set inside the well. Expansion joint, this one expansion joint give a chance like telescopic device, 2 sections together moving up and down to give space out because of the tubing elongation due to the effect of the downhole temperature and pressure during the production. You need to have design how many feet the pipe will elongate to give a chance for the expansion joint to elongate or extend the pipe to protect the connection of the top section, which is the tubing hanger. It is mostly used in water injection due to the cooling effect for water, because when you inject cooled water inside the well, it starts the string to shrink. So you need to have expansion joint to compensate this effect. It is defined as stroke length. Actually, the stroke length or the movement, it is around 10 feet to accommodate the expansion. Here is the sliding side door or SSD. The design for the SSD is temporary connection between tubing and annulus for killing operation or circulating, or to provide selective zone isolation between 2 zones. You can select the bottom or the top zone based on the design. The SSD normally is running in closed position. That means the port here you can circulate from. You have 2 slides or 2 pipe inside each other. The outer one contains port, but the inner one or the inner sleeve is blind. So, and have another port in the top. When the two ports coming toward us, so the connection will be open between tubing and annulus area. The features for the sliding side door, it is contained in the top here, profile to accommodate any nipple, and polish pore or polish seal area, inner sleeve with packing, and equalizing port. This one is equalizing port. When you open the SSD with shifting tool, so you wait some time for equalizing between pressure inside and outside, then you start to pulling out with the shifting tool. Usually the SSD above the production retrievable pucker, usually we leave one joint of the pipe and then we install the SSD above. It's not direct above the pucker. Why we leave one joint between the SSD and the production pucker? Any answer? Why we need to have one pipe joint, full joint, 30 feet, as a space between the SSD and the production pucker or retrievable pucker here?
For correlation later with wire line.
For what?
Correlation later with wire line.
No, it's not like this. Usually this joint we left because when you are going to circulate the well, so you open the SSD and you start to pump from reverse out or normal forward circulation. So when you circulate, there is some scale or sand inside the wall on the pipe. It will come outside from the port for SSD. So it will settle down. Where it will be settled? It will be settled down around the pipe joint you left 30 feet. So when you are going to close again the SSD, it will not plug the port for SSD and prevent to closing again. This is to keep height for if you have any settling for sand or depresses, it will be settled around the full joint for the pipe outside in the annulus. It will not affect the circulation or affect the plugging the port during circulation. But if you install the SSD direct above the pucker, it can be plugging with the accumulation of the fine sand or depresses coming through the circulation from tubing to annulus area. That's why we need to have at least one joint space between the SSD depths and the pucker. And usually we install the SSD near to the pucker to have the lowest point for circulation to kill the well completely from nearly from the bottom above the perforation. Okay. You have types for the SSD. Normally, as we said, we open by slick line. We open by tool is called shifting tool. We can jarring up with jar to open one type, and another type is jarring down to open the SSD. And for sure, the reverse for close. You will jar here down to close, and here you jar up to close. This one jar up to open, and this one is jar down to open. You have two types, XU and RU. U, this refer to up. You jar up to open. When you see in any completion accessories XU or RO or RU, you know that it is using jarring up with shifting tool to open the port for the SSD. When you see XD or RD, D refer to down. It's come from D down. So it is jarring down the shifting tool to open. What about X or R? This is the nipple profile here in the top of the SSD. You can set X or R plug in the nipple profile at the top for sliding side door. Can be installed several number on the one tubing, but one type. You need to select jar up or select jar down in all SSD inside the tubing or in the tubing accessories. Why? To not make confused for the operator for the slick line. All jarring up or all jarring down. Here, the schematic for SSD sliding side door. This is the position for closing SSD. The outside port here, which usually is small, is closed because the inner sleeve here is shifted its port to down. So this one, usually when we run the SSD, we run in closed position while running the completion. And then we start to flow the well. If you need to kill, you run with shifting tool. This one start to jarring up here. So the port for this inner sleeve will come through the outer port here together. So you will open communication between tubing and annulus. This one in open position. After you finish your circulation, you need to close again. So you upside down the shifting tool and you running and you start to jarring down to shift the inner sleeve down again and you close the SSD. The SSD or shifting tool is referred to the wireline section. Is not will not go deep in this point in coil tubing course, but at least you need to know some information. So the SSD, before you need to open the SSD, you need to equalize the pressure from outside and inside the tubing. You need to have equalization. So you need to calculate the hydrostatic head pressure plus any surface pressure inside the tubing and the hydrostatic pressure at the port for the SSD. And you need to equalize the pressure before opening the SSD. Okay. This one is the shifting tool. You have dogs here with shear pins. When you jarring down, you're running in hole, you pause the SSD and you start to coming up. So you hang with this dogs in the inner sleeve. Then you start to jarring up to move the inner sleeve out from its place to open the SSD. If you need to close your reverse upside down the shifting tool, okay, then you're running to jarring down to close the SSD. After you open the SSD, you need to check that the SSD is completely open. So you will start to circulate with return as a surface to confirm the SSD is completely open. In some cases, the SSD you try to open, but it is stuck in closed position. At that moment, you need to perforate the pipe, but in this case, you have to punch the pipe or perforate the pipe. But this moment, you need to recomplete the well. You will pull the tubing out. That's why the SSD is temporary communication. You can open and close when required for circulation or killing purpose. Shifting tool also can be connected to coil tubing unit. If the stick line capacity or the pulling capacity is not enough to open the SSD, have option to connect to the coil tubing and you're running to have greater capacity for pulling to open the SSD. After that, we'll go to talk about the side pocket mandrel or SPM. You have different numbers for SPM, side pocket mandrel, to contain gas lift valve for gas lifting process if you are going to produce the well after natural flowing with the gas injection. Designed for gas lift system, but also this one is communication path, this cross section for the gas lift valve or side pocket mandrel. It's called side pocket because there is pocket in the side here where the gas lift valve can be installed. It's installed by also slick line like the SSD opening. This one also part for communication device. You can also pump from annulus through this area inside the pipe, or you can pump from the pipe through the annulus area. For gas lift, you will pump high gas pressure from annulus. It will enter through the port for the gas lift valve installed in the side pocket here. Then it will be open the port to lift the oil inside the tube. Features for the side pocket mandrel: you have full bore, full tubing bore, no restriction inside the bore for the side pocket, and orienting the sleeve. There is orienting the sleeve here in the top for the section for the side pocket mandrel. It is allow entering for the kick over tool with a slick line to set the valve inside its place in the side. So you need to have orienting to slide the tool to the side here to set or retrieve valves. The valve can be set inside this place is around its diameter or outside diameter 1 inch or 1.5 inch only. What is type for valve can be set? It can be dummy valve, DV, this one, has packing element from top and bottom for isolation. If I am not planning now to gas lift the well or lifting the well, so I will install this side pocket mandrel and install in each mandrel dummy valve. The dummy valve is two-way valve, isolation valve. It is isolate annulus from the tubing, and I can produce natural flow through the pipe. If I need in the future to convert to gas lift, so I will run slick line in each pocket mandrel to retrieve the dummy valve and install gas lift valve. The gas lift valve, there is port and there is design for gas lifting. Each valve is open at certain pressure. I will start from top to bottom for gas lift. Then this is one-way valve. You pump from annulus through the string, the gas. It is prevent the backflow from tubing to annulus again. So you can install dummy valve or gas lift valve, GLV, or chemical injection valve. This for inject any chemical to prevent like corrosion inside the pipe. Or it can set also circulation valve. This circulation valve less cost compared with the gas lift valve, more expensive. And this one I install if I need to circulate or kill the well using for communication device. This one-way valve, I can pump from annulus to string, or I select from string to annulus, one-way valve, circulation valve, or another valve is called equalizing valve or differential dump kill valve. This also work on differential pressure to also for killing operation. This is the PK2, the latch or the top for the valve, where the running tool for the slick line coming to latch to retrieve any type for this valve. I will share video with you about the gas lift mandrel to be easy for us. This is the kick over tool running with a slick line to open or to install valve or retrieve valve from the gas lift mandrel. I think you can see the video. I will start the video now. You see the video, right?
Yes.
Okay. This is the orienting sleeve in the top. And this is the arm to coming in the side for the side pocket mandrel to install one valve here. Then it is released, then it's coming up, hit the top for orienting the sleeve, straight back and come out of the hole. This tool is called kick over tool. Clear? Back to presentation. This one. This one, the side pocket mandrel cross section. You can find here this, we install here gas lift valve. There is port one-way valve to accept the gas passing through this one based on the design, coming inside the string, reduce the hydrostatic head for the oil, lifting the oil to the surface. This one is a kick over tool. If you need to retrieve this valve in the side pocket, so we run with kick over tool, KOT, with a slick line, run till you tag the bottom for the tool, then you pull up. So this arm will be oriented from orienting the sleeve, coming in the side here to retrieve the valve, then back here again, hit the top here, orienting and straight and pulling out from the hole. Then we'll talk about the blast joint and flow coupling. As you see here, the flow coupling is this section, the white section, small one, and the blast joint usually installed across the perforation. So why we need to install the flow coupling? The flow coupling usually designed to withstand internal corrosion and erosion also caused by flow turbulence. So you have here nipple for subsurface safety valve, or you have here another nipple. Usually when the flow passing through the nipple, there is restriction in the nipple, so its velocity will be increased. The high velocity fluid it can create turbulence and it can start to make corrosion for the tubing above. That's why we install the flow coupling above any restriction, or sometime below and above any restriction. Why? Because the flow coupling, the same idea, but the wall or the thickness from inside is heavy thickness. That's why the turbulence coming from the restriction inside the nipple, the flow will start to eat or react with the heavy wall of the flow coupling. So it will save the life for the normal tubing above. So this one designed for internal erosion due to the high velocity of the flow passing through any restriction. So this one is short tubular with stainless steel heavy wall from inside, installed downstream flow control device, which cause turbulence like nipples or above SSD or subsurface control safety valve, any restriction in the string. Usually you install this one above to accommodate or withstand the internal erosion. In high velocity or high pressure well, Usually we install this one upstream and downstream. If you look here, this one is nipple profile. When the flow is coming through, its velocity will be increased to the maximum due to the small area. So I installed here flow coupling above. So the flow coupling have heavy wall from inside. So we'll start to deal with the or withstand the internal erosion. In this case, I will save the life of my tubing or tubing string. So extend the life for the tubing and prevent any erosion in the tubing. The reversing is for blast joint. The blast joint is section of the pipe also, but this one to withstand external erosion. So the wall from outside, it will be thick, heavy from outside. That's why I installed this one across the perforation. Instead of install here normal tubing, so I set this blast joint across the perforation. When the flow coming from the perforation with high velocity, especially if including also sand, it will start to react or deal with the high thickness from outside pipe, which is the blast joint. So it saves the life for the normal tubing. That's why here is designed to withstand external abrasive action from the formation fluid, medium length around 20 foot with stainless steel heavy wall, and usually the flow coupling around 1 meter, like 3 feet or 3.5 feet. Installed opposite perforation. The perforation is normal one, is non-gravel back completion, open hole. This one is called ANNULUS safety valve, ASV. You remember the tubing retrievable safety valve, it is prevent backflow inside the tubing. The same here for ANNULUS. This type usually installed in the well completed with gas lift. When I start to inject gas in the ANNULUS with high pressure, okay, and then coming through ANNULUS safety valve, from ANNULUS safety valve start to enter the string for lifting the well. If I have here damage in the wellhead or the Christmas tree, so the high pressure gas in the ANNULUS will start to escape and release to the atmosphere, which is very dangerous high pressure gas. That's why I installed something called ANNULUS safety valve to stop any flow back for gas in the ANNULUS if you have damaged or explosion or any repair or any damage at the wellhead area. This only especially with the gas lift well, like so the tubing retrievable safety valve disconnect communication inside the tubing, and here the ANNULUS safety valve, it is prevent any backflow for high pressure gas in the ANNULUS due to gas lift to escape to the atmosphere in the event of any damage to the wellhead. This one is working also with control line from the surface, like the tubing or subsurface safety valve. When the pressure at the control line 5000 psi, it is open, allow the gas to pass through the ANNULUS safety valve down to the side pocket mandrel to the inside the string. When I cut the control line pressure, so it will fail safe. It will prevent backflow like one-way valve in the ANNULUS to get the or escape the high pressure gas to the surface. Usually the ASV is running one joint below the tubing safety valve. Below the tubing safety valve, I will run the ANNULUS safety valve. It can be separate or part with the top pucker if we install the top bucket. Clear? Then we'll talk about the control line. Usually the control line can be quarter or half inch OD connected to tubing return safety valve or safety valve landing nipple for wire line return safety valve and terminated at tubing hanger. It is passed from fitting through tubing hanger through the wellhead to the surface, connected to the reservoir and hand pump to inject high pressure gas through the control line to control the subsurface safety valve or annulus safety valve if installed. The control line while running in hole attached to the compression string or the pipe from outside and should be flushed and cleaned with control fluid and tested before it is shipped on drum to the well site. It can be clamped, attached with clamp, steel clamp to the pipe and run from the 300 feet depth for subsurface safety valve up to surface through the tubing hanger. This is tubing hanger neck and this is the control line coming through, terminated through. The material for control line selection is based on the H2S inside the well or it is a sweet surface. For sweet surface, there is no H2S or CO. We use 3-116 stainless steel alloy for the material for control line. If you have sour well or H2S, so we will have nickel or copper nickel alloy steel. This is to prevent the corrosion for the control line while production. The last thing on the top for the production string is the tubing hanger. The tubing hanger accommodates the string, hold the weight for the string, and landed in the tubing head spool. So usually sit in tubing head spool in the top section. Function: suspend tubing string with thread connection from bottom, so that string for compression is connected from bottom. This is single tubing hanger, this dual tubing hanger, and this tubing hanger with control line port to pass control line or ESCP cable through the tubing hanger. Isolate also casing tubing annulus. You have packing element or seal element here. So isolate at the surface tubing from the annulus. Provide access to annulus and control line. And receive back pressure valve and two-way check valve inside. You have types for the tubing hanger: ball and MANDREL tubing hanger. This is tubing head and tubing spool. This is a tubing spool or tubing head spool where the tubing hanger is set inside its profile. Usually the tubing hanger, the same manufacturer for tubing hanger and size and working pressure, the same profile or the same manufacturer for the tubing head spool. If the wellhead is FMC, 11-inch this internal diameter for the spool, so you need to have tubing hanger 11-inch OD because with the same FMC manufacturer to set or take its place inside its profile. And you can have multiple MANDREL tubing hanger. This is in case you have multiple completion. So you will have two ports here for the tubing hanger to accommodate each string, which is short and long string. This is cross section in the tubing hanger. There is 3 connections for the tubing hanger. top thread and bottom thread, and there is middle thread, and this is the packing element for set inside its profile. Bottom thread, this one is to connect your pipe, tubing string. And top one is to connect one joint or two joint to lower the string from the rig floor to the wellhead at the sub-base level. So you need to have landing joint after you run tubing hanger inside its place. You will disconnect the landing joint from. Middle connection here is to accommodate back pressure valve or two-way check valve. The back pressure valve is one-way valve set inside its place here by running tool, or two-way check valve. This is isolate from two-way, isolate the pressure from top and from the bottom. This is tubing head spool, where here in the top is the profile for the tubing hanger. And after you install the tubing hanger in its place, you will screw this lock down screw around the top of the tubing hanger. By this way, you know that the tubing hanger is landed correctly inside its profile. Here below, this is side outlet. There is valves here to 116, usually hand valve. Operate to check the annulus between the tubing string and the surface casing. And here, this is injection point for lubrication, and this one is test port for testing by hand pump seal for ring gasket when you connect flange to flange. This one is tubing head spool. This look down screw here. The tubing hanger will be set in its profile in the top, and this is the valve 2116 side outlet valve. This one is ABB Vitco Gray. This is manufacturer for the tubing head spool. 11 inch by 11 inch. That means the top and bottom ID is 11 inch from inside. 3K, that means rated working pressure for the wellhead is 3000 psi. So in this case, you need to have tubing hanger here, 11 inch, 3K, ABB Vitco Gray to set inside its place. 3.5, that means the connection from top and bottom for the tubing hanger is 3.5, for example, UE connection for tubing or valve. This one is a one-way valve, back pressure valve. Do you use this back pressure valve before?
Yeah.
Okay. This is back pressure valve BBV cross section. Here you have left thread here to connect the back pressure valve inside its profile in the tubing hanger, this cross section. The back pressure valve is one-way valve. You can pump through, just open the spring down. You can pump down the string, but it is prevent the back flow. That's why it's one-way valve. This one has barrier, but you need to inflow test the PVV to ensure it will hold pressure from inside, from down. It can be capable of handling 15,000 psi differential pressure across the back pressure valve. That's why it is also considered as a barrier if you need to change any valve in the Christmas tree above. To install back pressure valve under pressure with lubricator section and running tool through the Christmas tree valve. After you set in the place, you need to check the inflow test, check it is holding pressure or not. So you will release the pressure from the above and you keep the pressure from below to check its integrity for back pressure valve. This one, the another type in the same place for PBV, I can install, retrieve the back pressure valve with retrieving tool and I can install the two-way check valve, TWCV. This one is holding pressure from top and from bottom, is blind plug. Here there is packing element to seal in its place. Like also the packing element here, you need to check visually before you install in its place to seal in its place here. This one also used when you are going to pressure test the connections or pressure test the Christmas tree valves. To install tubing way or two-way check valve in the tubing hanger, you start to apply pressure against the two-way check valve to pressure test some valves above. This valve capable of holding pressure from both direction, and it's like it's on the previous page. It's installed in the thread profile in the tubing hanger, capable also to pressure test Christmas tree, and can withstand also up to 15,000 psi differential pressure. That's why it is well controlled barrier. After that, we'll talk about the wellhead. What is the function for wellhead? You anchoring and connection each individual casing with casing slips, pressure isolation casing from casing, have connection for Christmas tree, connection for compression string with tubing hanger at the top, isolation production annulus, have access to can monitoring the annulus while production or while pumping. There is two types for wellhead, conventional one for surface wellhead and compact wellhead for subsea wells. The subsea wells, the Christmas tree will not disconnect for completion, but it is landed on the seabed in the subsea completion. This one for subsea application. This is the compact wellhead and the tubing hanger here. When you need to retrieve the completion, you retrieve the compression string through the Christmas tree. You don't need to retrieve the Christmas tree like the surface application. Conventional wellhead. This one, annulus A and B and C. In the top here, this is annulus between tubing hanger, string, and surface casing, and each annulus B and C between two casing to monitoring the pressure while production. This conventional wellhead, you will start here with Braden head, then casing spool where the casing here landed in its casing hanger, and the tubing spool or tubing head spool where the here tubing hanger landed and hang the string for the completion. And if you look here, there is control line coming through the tubing hanger to the surface. So now how we can connect the flange for the wellhead to the Christmas tree at the surface. You have something called double stud adapter flange, like this one. It is convert the size from bigger size in the bottom connected to the tubing head spool, like 11-inch, for example, by 318. 318, this is the top section of the flange. So you can connect the Christmas tree flange to flange on the top. In some cases, you have Christmas tree can be 4116, 318, or 7116 based on the design for the well. The Christmas tree, this is the conventional Christmas tree for surface application. You have some valves to control the flow or the routing of the flow from the bottom to the surface line. The features here is lower master valve and upper master valve. This one is flowing wing valve or flow wing valve, and this one kill wing valve. And the top one is called crown valve, or sometimes we call well intervention valve, because this valve is the first valve is closed by hand after the coil tubing or well intervention tool coming out above the Christmas tree. The lower master valve usually is manually and usually is kept in open position in all cases during well intervention operation and during the production phase also. So why this valve, lower master valve, which is manual, kept is not working valve in optimum condition, is kept in open position? Why?
What was the question again?
Why the lower master valve, this valve, usually kept in open position? No need to close or open during well intervention operation or during production phase.
Not sure.
You close this valve during coil tubing?
Yes, we close everything and open everything. And once we run in hole, we open everything, of course. And once we finish the job, we close everything.
In your Christmas tree, you have lower and upper master valve, or only one master valve?
No, we have two actually.
The top one is manual or hydraulic?
No, all manual.
All manual. Okay. According to the API, this valve we kept usually in open position in all situations. Why? Because this is last option to close in case of emergency. What mean in case of emergency? If you have failed in any valve above, this one will be your barrier to close to repair any valve above. But if you are from beginning open and close this valve many times, it can be failed, right? If you need to change the lower master valve, that means you need to install extra plugs inside the string. That means more cost for your operation. That's why this one is called last resort or last option, not working valve during optimum conditions. Okay, you get the point?
Okay.
Usually, when you pull out with the coil tubing, first valve we close this one, which is called usually well intervention valve. After that, you have option to close the upper master valve to secure the well from below. But this one will not close if only this valve is one valve. In some Christmas tree, it does not come with two master valve, only one master valve. And you have after that upper master valve. The upper master valve is called emergency valve. It can be manual, or in most cases it can be hydraulic or pneumatic operated. It is operated from control line connected for open and close this valve, or connected to air supply, pneumatic pressure to operate this valve. You don't have any wheel or hand to operate this valve. The upper master valve, in some cases or some design, has ability or has cutter to cut only slick line, the single wire, the small wire. In some cases, it has. That's why the Christmas tree valve in a slick line can be considered as tertiary barrier if the upper master valve is equipped with cutter in the gate to cut the slick line. It's not E-line, only a slick line. But you need to check with the manufacturer for the Christmas tree if this upper master valve can do this job or not. flowing valve, this is for production. You have choke valve here, adjustable or fixed. And usually we use the choke valve here or the choke to choking the flow. According to the API, we're not allowed to use these valves to choke the flow for the well. Only the choke can do this choke. Restrict or control or regulate the flow of the well fluid. And this valve is the kill wing valve. You can connect your pump if you need to pressure test the Christmas tree or to kill the well. In some cases, we don't have this valve. It is blind flange to reduce the cost for the Christmas tree. This one is, last one is the top one, is called crown valve or safety valve, swap valve, sorry, or well intervention valve. This permit entry for well intervention tools. All valves in the Christmas tree is considered as one carrier. One body, that means one barrier, because all valves is considered as one barrier. If you need to change any valve in the Christmas tree, you need to have minimum two tested barrier. That means I will close the lower master valve or any valve above, below, and I will install first also back pressure valve and make integrity for this one. So we have two barrier before going to disconnect any flange to change the valve. This valve is designed to hold the pressure from which direction? Christmas tree valves. From which direction is designed to hold the pressure? This question, from which direction Christmas tree valves is designed to hold the pressure?
Should be from both.
Okay, what also? Another answer? Mr. Abdullah said that from both direction. That means from top and from bottom. All agree about this?
Yeah.
Actually, the Christmas tree is not designed to hold the pressure from both directions. It is designed according to the API to hold the pressure from the direction of the flow. You close this valve, you apply pressure from here, not from this side, from the direction of the flow. The same for this valve. When I close, I allow to pressure test from below, from the direction of the flow. The same for both valve. It's not designed to hold pressure from top. If it is hold the pressure from top, with the time it will leaks. The gates itself, it will cause the valve to fail and leak. This is according to the API. And also according to the API, you need to equalize the pressure before opening the valve. If you have pressure from below, you close the Christmas tree, you need to apply pressure from top before you are going to run with coil tubing, for example, right? Because the valve is not, it will cause damage to the stem or the internal of the valve, which is normally gate valve. So you need to equalize the pressure before opening any valve, because if you open the valve under pressure, it can cause damage to any tool above. That's why you need to equalize, especially for coil tubing or wire line entry high pressure well. Okay, any question?